Hi, this is Mrs. Pound, and I'm back with the final section about minerals for this chapter, the second chapter of Purposeful Designs, Earth and Space Science. So today, yes, last video we talked about some general properties of all minerals, properties that we look at for all minerals. For example, luster and streak and hardness, and we would measure those for all minerals. Today we're going to talk about some special mineral properties that only certain minerals will demonstrate. So let's get started. So our objectives today are to describe several special mineral properties and to assess the usefulness of special mineral properties in producing a definitive identification of a mineral sample. The first special property is taste or solubility. This is only true for minerals that dissolve in water, so it must dissolve in water, and there's a little bit of a warning here. It's not really that safe because some minerals are toxic. We do not want to go around tasting all of our minerals. Okay. One that does demonstrate this is halite, sodium chloride, which is table salt, and obviously it tastes salty. We've all tasted that. But we don't really want to go around licking the mineral samples because it could be a toxic mineral. So a little bit of caution with this one. Only do it if your science teacher tells you to, right? Okay. The next one is smell. And this is usually only discernible when the mineral is struck, as in if you hit it on something, or it's freshly dug up. An example of this are sulfides, and pyrite is a sulfide, fool's gold. They smell like rotten eggs. So only some minerals will demonstrate this, and it could be kind of hit or miss depending on if you strike it on something or if it's freshly dug up. Reactivity. This one is a really good one. This is very useful. Some minerals fizz when reacting with hydrochloric acid, for example, calcite. So we will see this in class. We will put some hydrochloric acid on some calcite and we will see that reaction. Flexibility. This is the ability to bend without breaking. Biotite mica. I don't have a picture of this one. This mineral is very flaky, and I will show it to you. It's kind of black, and it's very bendable. So I will show you an example of this in class. Magnetism. Some minerals are attracted to a magnet or possess the ability to attract iron. One of these is called lodestone. It's a piece of magnetite that naturally acts as a magnet. Sailors originally used this to make compasses, okay, so that they could navigate and know which way was north and south. So they made compasses using lodestone. So very historic there. Fluorescence is another special property, and this is the ability of a mineral to glow and change color under ultraviolet light, so a black light. And you can see here, this is a sample of willemite, calcite, so kind of calcite. This is it under normal light. This is it under ultraviolet light, a black light. So they will glow like this, and so that is very characteristic of some minerals. I do not have the ability to show you this in class because I don't have a black light, but just be aware of it that you could do this. Phosphorescence is the ability of some fluorescent minerals to continue to glow after an ultraviolet light is no longer focused on them. So that sample we saw before, if you took the light off of it and it kept glowing, then it would be phosphorescence, okay? Not just fluorescence, if it continues to glow. There's also double refraction. This is the ability of a mineral to produce two images when light bends passing through it. And calcite does this. Now, I'm not going to be able to show you this in class. I tried it, but my samples of calcite are really rough and not smooth enough to do this. But you can see in this image There's a beam of light, a laser light going through this. There is some reflection off this way. We're going to ignore that. The main beam of light is going through here, and when it comes out the other side, it's split in two. That is double reflection. It got bent, okay, twice, because that's what refraction is. It's the bending of light due to changes in speed when it goes through a substance. So calcite exhibits this. Another thing we might look at is texture, how the mineral feels. And so I have lead pencils here because we know that the mineral that is inside lead pencils is not lead, it is graphite. And if you were to rub graphite on a piece of paper, which I'm sure some of you have done, and got a lot of graphite on paper, and then feel it, it feels what we call that greasy feeling. It's very slippery. That's why graphite is also a good lubricant, like if you're prepping your car for the Pinewood Derby or something like that. And the last one is radioactivity, which I'm not going to be able to show you in class. I do not have any radioactive minerals, but this is the ability of an element to give off nuclear radiation as a result of a change in the atom's nucleus. This could be dangerous. That's why I don't have it. An example is uraninite from uranium. And what you would need is you would need an instrument called a Geiger counter, and that Geiger counter would pick up the radiation. And so if you're not sure about what a mineral was, it looked like two, and one was radioactive and one not, you would be able to use this instrument to be able to tell. So our objectives for this lesson were to describe several special mineral properties and to assess the usefulness of special mineral properties in producing a definitive identification of a mineral sample. As I said, when I went through this, some are more helpful than others, and some are kind of dangerous. So you can use some of these and not others. Okay, so like I said, some useful, some not as useful, but interesting and could be used. So this finishes the chapter on minerals.